now we go into the discussion points. So all the speakers of the session actually were very thorough and wrote even their names to the points that they wanted to discuss. I'm gonna read some of the highlights and then I'll open the floor to discussion. Kyrie says, is it worth projecting single epoch images onto a common pixel grid and unifying the PSFs? Neven is, well, we want to do efficient time domain science, how we can access quickly to fast catalogs, to survey catalogs. Gillian is talking about the high latitude time domain survey that we want to get transients. Of course, type 1a supernova are an excellent probe for the nature of dark energy, and it's very promising, but I'm pretty sure we can also discuss other probes in Roman. And Rebecca is saying that given the nature of Roman, we will have very early information for rising type 1a supernova. And this is interesting, and I'm completely biased because I work on this, because we can see progenitor systems and understand how the explosions occur. Anybody wants to have any discussion about this or any questions you didn't have time to ask? Yes.
Thank you. This is a question for Rebecca that maybe I should know, but
you're on our team, Sebastian.
yes. So what is the biggest difference between Campari, like the high precision photometry, and like what the SOC is doing? And is there a reason why those calibrations are not in the default SOC pipeline?
So the difference between SSFT and Campari is the first part of the question, and the second part was?
So the Campari is doing super high precision photometry.
Yeah, using C modeling. Yeah.
Is there a reason why the SOC products are not doing that?
I don't know if that's a question for me. I mean, okay. C modeling, it can be computationally expensive. There are lots of different complications around that. And I don't want to speak for the SOC. Is there somebody here who could speak for them, Ori? So why would the SOC not do C modeling? My thoughts would be because, you know, the SOC is providing the tools for the public in general. I don't know what exact techniques they're going to be applying to obtain photometry for different things, but maybe resources or providing tools for the more broad different things. So why would the SOC not use these C modeling kind of tools for doing photometry of things? And I imagine there's lots of different reasons.
Yeah, I think that it's just a much more complex routine, and that for I think it's safe to say that the primary goal for the SOC is to do photometry for the broader community, not for specific science cases.
So that's exactly what I thought that would be, but and so, yeah, C modeling can take time. You know, the way in which we're delivering our products is different to the way in which the SOC is going to be delivering things as well. So, and, you know, we have to take into account lots of different calibration things as well, which we're starting to discuss within our team too. So lots of different reasons.
I have a microphone now, so I can pass this on. Any other people that have questions or discussion topics? I actually have one as for Gillian and Rebecca about the last point. So if we're going to get early type 1a supernova, have you simulated some shocks that we can characterize with Roman?
We have not, as far as I am aware, but I love the thought of that. That's really interesting. And one of the reasons I also bring it up is because I'm also biased and I also work on TESS, and TESS, you know, has been used to get early light curve information. There's been a lot of work done by Michael Fausch now on this area. So I kind of jumped on this because, yeah, we will get these beautiful early rise light curves of not just supernovae, but other objects as well. And what can we learn about these physics of these objects through that? So no, but that seems like a really interesting science thing.
Excellent. Anybody has thoughts about early type 1a because I'm biased or something else?
No, it's about the early type 1As. How many, I missed it, how many magnitudes below peak can you start getting in with what cadence?
You mean for Roman or
yes,
for
well, whatever you're referring to in that last bullet, I guess.
So for Roman, you know, you are talking about 5-day cadences but with the bluer band, 10-day cadences, apart from the bluer band, which will be every 5 days. So that's the cadence for Roman. In terms of what the signal to noise limit will be and the limiting magnitudes, I'm not 100% sure about that off the top of my head. Gillian, do you have an answer for that? Miss Addis.
You just need to go 3 or 4 magnitudes below the peak before you'll see any of these early light curve excesses. And then you need to sample them at sub-day rest frame cadences if you really want to measure something. So.
Yeah, I think if you want a statistical sample, probably 3 magnitudes below peak at around redshift half or so. Does that answer your question?
Yes. But it's also a higher redshift than before. Like until now, we have only seen bumps very close by. Yeah,
I guess I was just wondering if you have a big ensemble of things, you detected several magnitudes below peak, and you can kind of piece together populations of 1As and learn things about bumps because you have 100 1As with one detection of a bump or 1,000.
Yeah, and part of exactly on that point of part of me thinking about this was like, you're not just going to have Roman, you might have things from Tesh, you might have things from other facilities as well. So this is adding data points to other things, and that excites me quite a lot.
Any other comments about the controversial early type 1A bumps? I think really like going deeper in redshift is going to be great because until now, all the bumps have been very close by. And in rest frame, like we will have a little bit more wing room maybe because we're going further down in redshift. Any other comments about these or any of the other points or questions missing from the session? Yes.
Question to Rebecca. So you have to classify the supernovae, what type of supernovae. So you will get all type 2 core collapse supernovae and other types. Yeah. So what are you going to do? Will you be able to collect them and somehow other people can use them?
Yeah, no, this is a great question. So we are tasked with delivering the 1A stuff, but we'll obviously have the stuff for other objects as well. And we've been thinking about, releasing that and how we might go about doing that. We're all about, whatever information we have, we'll release to the community as soon as we have it. So we can release the probabilities of it not being a 1A and being something else as well. The exact method through which we'll do that will obviously have to be for discussion with, everybody.
Are there any plans to have other cosmology probes, like transient cosmology probes with Roman?
You mean like red giant
Core collapse
stuff?
supernova?
Yeah. I haven't looked into that.
Yeah. No? Okay.
I was also wondering about, maybe you mentioned this and I missed it, lensed 1As. Is that part of the plan too?
I don't know. They're being pointed to you, so.
Sorry, what was the question?
Yeah, lensed 1As in the supernova cosmology pit. Is that like?
I mean, that'd be super cool. I don't know if Ori wants to talk about lensed 1As at all. That's it, back and forth.
No, it's not my field, but there's definitely proposals in I know to do that. And you don't just need, the time domain survey. You can find lens supernovae in the wide area survey, and it doesn't even have to be just 1As. You can do cosmology, of course, with core collapse. But that's a whole nother field and a lot of other talks. So
the reason I brought it up is because Justin Perel, who I know is very interested in lens 1As, he's on our team. And so this is something that he's incredibly interested in. But in terms of, we'll provide, like I said, information when we find something in general to everybody. But yeah, Justin would really be the person to talk to about that.
We have still a couple of minutes. The density of questions from this side is huge. The density of questions from this side is 0. So if you want to change the statistics, it's your moment to raise your hand.
I have a question for the audience, if not, and I can specifically look at the people over here. What would you like to be seen to come out of the SM PIP? What products would you like if we haven't already stated them or provided them or discussed them? What else would you like? And if it's nothing, that's great. And we've done our job perfectly. Wonderful. Right.
I think Kostya has something, Ashish. Yes, this is controversial. We have Kostya, Ashish, and Jacob. Perfect.
I missed parts of the talk, sorry, but maybe it was mentioned. What about spectral simulations like RISM and stuff?
So I can talk about the PRISM. So we are working on that. We have been working with our folks over at Duke, so Arun and Troxel and Claire, in addition with people at Space Telescope, to include the most recent optical model from folks over at IPAC to make up PRISM images, essentially. And we have started doing that we have images now created, and we're working on making them. We've done them in the Raman data model, and we're working on making a good sample of them, essentially. And we've been injecting transients within them and extracting them. So that is something that we're actively doing. I'm hoping within the next week or so. So we certainly need to give some of these to IPAC, but I'm hoping that we can also just release to everybody in general. And so with supernovae injected into them, so that you can look and play around as you wish with the data as well. So yeah, we're working on it.
We have Ashish and Jacob. Ashish, Jacob, and maybe Ori. Yeah, well, Jacob.
Should I start? Okay, since you're asking, so this was something I talked with Ori earlier. You could take the simulations you have, generate alert-like streams out of those, supplemented with the photometric redshift information that you imagine will be that, and release that. That would allow other people to both train classifiers, do cosmology, and ideally in a blended fashion.
Yeah, we can certainly do that. We can provide our truth tables with the images that we're creating and release it to the community.
Ashish and then Ori, and then we'll wrap up probably.
So this actually connects to the Hourglass 2 also, and going back to Open Universe 2024. So even in Hourglass, what I noticed is that there are more explosive events and not variables. That's by design, I know. But in general, that makes it non-trivial for machine learning to pick those apart.
Right.
And so if you want purer samples, is there a way to make it somewhat more uniform? It's, again, I would emphasize that machine learning can separate that, but life would be easier if there are ways that are provided where there is connectivity with how variables will look in your kind of simulations, for instance, rather than someone trying to devise that out. So are there thoughts about that, for instance?
So would you like, so I am originally a NOVA person, and like cataclysmic variables, that kind of thing is my jam. So you would like, and let me see if I understand, would you like us to, or have people to have the ability to inject variable sources into the images that we have?
Correct. That way it will be on par with the explosive events rather than having to do it separately somewhere or looking at light curves that come from some other sample. So there will always be some biases that need to be matched. And if it is more generic inbuilt, that would be so much better.
So I love this question. It's great. One thing I would really like is if there is some kind of object that you would like to be included within what we are simulating, if you give us information about it, we can put it in. So right now we're using the truth tables from the Open Universe 2024, but that's based on what Rick Kessler did, I believe.
Yeah.
And so if you can give us information to us about like the different models,
maybe that is why Kostya is raising his hand, but the light curve links has a bunch of models.
Right.
And those are just light curves though. So if you could pick those up and put them into your simulation, so they're in images, we recover them and see if we get the same thing. And the main thing that we may want to do is to see how these light curves behave when we go to infrared, when we go much fainter, because that is where, again, there are likely to be more biases that come in.
So it sounds like we should have our own little hack session with injecting sources and different things into images. I love this idea. Thank you.
It would be great.
I'm sorry, Ori, we're running out of time. You can talk to Rebecca in a second. Okay, I will make it, and nobody answers, just in lunch.
It's actually just a raise of hands. Now you've seen talks from the rapid session and the Supernova 1A session pits. I'm wondering, you know, this might be the first introduction to some of you or many of you. I'm curious now, how many of you, you know, Rebecca said it, what other things should we do? And nobody gave any feedback, but I'm curious, how many people are planning to use Supernova 1A data products to perform their science with Roman? If you can have a raise of hands that isn't in a Supernova 1A pit. All right. And how many people are planning to use the rapid products for their science that aren't in the rapid pits? All right.
Okay. We're gonna stop now. You can continue this discussion during lunch. Before we go to lunch, I think Brian will tell us about what time we're coming back.